Now we're back to our chart of the three equations for finding H, and we can take the first principles equation and expand these terms so that we can see how this equation can be used to actually solve for H. So first we'll do it without compounding. And you'll recall that the formula for dn is dn equals d1 times 1 plus hb times tl over the conversion formula, the conversion factor. So when we substitute this in here, then d1 on the top cancels with d1 on the bottom, and the rest of this comes down here. You'll also recall that v1 equals h1 times d1. So we substitute that in for v1, which gives us our final formula. One thing that we can do with this final formula is we can put it into a slightly more user-friendly form. So first we recall that the time the light traveled equals dl divided by the speed of light times the conversion factor. So then we substitute this in for TL here, and the conversion factor cancels on the top and bottom, and that gives us the final formula in this form, which is a form we're going to find very useful to use throughout this presentation. And here is the formula using the compounded equations. Now, you recall that dn, the compounded formula, was d1 times 1 plus hb times s over the conversion factor to the power of TL. So we substitute that in. And then, making the next step, the d1's cancel. And we know that d1 equals h1 times d1, so we put that in here, which gives us our final formula, where the ratio of the wavelengths equals 1 plus h1 times d1 over c times 1 plus hb times s over the conversion factor, all to the power of TL.